in order to graph this, hopefully you realize it's an exponential growth, and you know this is an exponential decay. We're going to make a table, and we got to choose our values. 0 is always your best value. So for this one, I'm actually going to start with 0. So I'm going to plug in 0 right here, and then 1 and 2. You sometimes want to plug in negatives, which you'll see in a little bit. I'm going to try a negative later. Now all I do is I have to plug that into the equation. All right. So now there are shortcuts, but right now I'm just going to plug it in. If I take the equation and plug it in, I'm going to show the work just to kind of show what's happening. I plugged in 0. 3 to the 0 is 1. So that becomes 2 times 1, which is 2. Now hopefully you're learning by now that that number is always your 0. So the 0 for this one's going to be 4. So the number in front is always your 0 with these basic exponential growths and decays. Later on it gets a little bit more tricky when other things happen. But for now, the front is your 0. Then I'm going to plug in my next number, 1. So if I did my equation, I simply plug in 1, which means 2 times 3, because 3 to the first is 3, which is 6. And then you plug in 2. But what you should notice is there's a pattern. Do you see the second number right here in the parentheses? That's what you're multiplying by each time. So if I start with 2, I multiply by that by 3, I get 6. So the next one you multiply by 3, which is 18. Or you could plug it into the equation. You could totally plug it into the equation and you would get 18. But it's easier to say I'm starting with 2 and I'm multiplying by 3 repeatedly. So the next step is going to be to graph it. So just plot these dots. Now are all the 3 of these dots going to fit on this grid? No. Only one of them fits, but we can fit kind of both of them. Watch this. I'm going to do 0, 2. And I'm also going to do 1, 6. So over 1, up 6 is right about there. So we got kind of 2 dots. And we should know what a growth looks like. Now, one thing I do want to point out, if I'm going multiplying by 2 down, what am I doing as I go up? Do you understand you're dividing? Sorry, if I'm multiplying by 3 down, aren't you dividing by 3 up? So what would 2 divided by 3 be? What would be that number above? If I divided by 3, what would that number on the right above be? Well, isn't 2 divided by 3 2/3? So at -1, wouldn't I be up 2/3? So could I actually put that dot to give me more dots? Now could I make my graph? Now this is going to get ugly because I can't draw very good on this. Oops. Okay. Your graph should look something like that. It should always get closer and closer to the x-axis, never touching. And the other side should always be going up, hitting the dots that you can fit. You don't have to have every dot, you just have to have the dots that would fit, at least 2 dots. So for the next one, because it's a decay, I'm actually going to put in a negative. There's a reason why. Because also on the test, I'm probably going to be giving you the specific table you have to fill in. So sometimes I give you negatives. I want to make sure you can do that. Now, so let's plug in -1. Let's just do the computation for this one. What is 4 times 1 to the 4th? Oops, that's a 4th. To the -1st. Well, negative powers do some flipping effect. So watch this. This is going to be 4. That -1 power goes to the top and to the bottom. I'm just doing this just so you can kind of remember how to do this. Which then becomes, you now flip these two. Negative powers mean they flip. So I now have, that's going to be 4 to the 1st over 1 to the 1st. And anything to the 1st is just itself. So what I get here is just 4 times 4 over 1, which is 16. Now that's way too big. Is that going to fit? No. But I wanted to practice showing how to plug a negative in. You don't have to on yours. You might not have. I'm just showing what a negative would look like. Now according to our pattern, is our 0 pretty easy? Isn't that going to be your 0? So let's just put 4. And if we're dividing by 4 each time, do you see here, if that divided by 4 got me 4, what if it's 4 divided by 4? So what's this going to be? Won't that be 1? If you're dividing by 4 repeatedly, isn't that 1? Now can I put some dots? Yeah, I can fit 0, 4. I can fit 1, 1. And I know it's a decay. Decays look like this. They kind of are going down, down, down. And they get closer and closer but never touching. So that's kind of what the graph looks like. It goes down, 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 down. If it's a fraction here, it's shrinking. If it's a value bigger than 1, it's growing. This number right here is how it's changing. So we're multiplying by 3 as we go down. We're dividing by 3 as we go up. Here, we're dividing by 4 as we go down. We're multiplying by 4 as we go up. Those are important pieces to think about when sketching. When you do these, all I need is 2 points and the curve should look good. And the curve should always go up against the x-axis, never crossing. That's important that you have this edge that kind of goes up against the x-axis. The x-axis is your asymptote. It's a line that approaches and never crosses.